Hi friends, welcome to Sevivali Kalvi channel. Hope everyone fine. So today we are going to see about theorems of DC circuits. So first let us see Thevenin's theorem. So before going to see the in-depth concept of the Thevenin's theorem, we have to know why we go for this Thevenin's theorem. So let us consider one active circuit. So which consists of three resistors R1, R2 and R3. These are all named like this, and one voltage source is connected, and R4 resistor is connected in between of the terminals A and B. So now this R4 resistor act as a load resistor. So this is the concept. So let us consider this example. So now we have to find the unknown parameter. So what is the current flow through this load resistor R4? So because here we have to consider this R4 is connected in between of A and B terminal. So this R4 is act as a load resistor. So we have to find what is the current flow through this R4 resistor. So with the help of three methods, we can able to find the unknown parameter of this current flow through this R4 resistor, which is load resistor. So first method is series parallel simplification. That means how many number of resistors are connected in series and parallels. Based on this arrangements, we can able to find this current value. Another method is branch current method. Last method is loop current method. So branch current means with the help of current divider rule, we can able to find the branch current. And loop current method means mesh current analysis method. So for more complex circuits, we can able to find this loop current for the particular mesh or loop. So these three methods can be used for finding the unknown parameter of the current value. So this is here complex and repeated calculations are used for calculating this load current IL. So to overcome this problem, here we have to use one new method which is called as a Thevenin's theorem. So to avoid the repeated procedures again and again, the same concept or method is used in this circuit, and to overcome this problem we can go for this Thevenin's theorem. So now it can be replaced given active network with the help of between of two terminals by constant voltage source, and we have to apply this Ohm's law, and we can able to find or determine the load current IL. So let us see the statement of Thevenin's theorem. So Thevenin's theorem is nothing but it is a linear active network with consist of output terminals A and B that can be replaced by a single voltage source, which is called as a VTH, that is Thevenin's voltage or open circuit voltage, in series with a single resistance, which is RTH, Thevenin's resistance, or RI. So where VTH is a Thevenin's voltage, so this voltage between terminals A and B on open circuit condition, so it is otherwise called as a open circuit voltage, and it is denoted by VOC. Here RTH is a Thevenin's resistance. So normally any particular circuit arrangement is whenever the voltage source is there, it should be connected with any particular resistor in series manner, and if the current source is there, the resistor should be connected in parallel with the current source. This is normal connection about this any particular circuit. So let us consider this linear active network, the terminal which consists of A and B, and the Thevenin's equivalent circuit which has a VTH and ZTH. If you consider this kind of voltage source, so in AC and DC circuit we have to differentiate the representation of voltage source. So whenever you have a DC circuit, the voltage source is consist of the two polarities, positive and negative, and instead of this ZTH we have to consider only pure resistive component, that is resistor, so which is called as a RTH, Thevenin's resistance, and voltage is VTH. In case instead of this DC circuit, if you suppose to use the AC circuit, the sign function of the signal can be represented in the voltage source, and ZTH is the impedance, which means it consists of resistance and inductance, or resistance and capacitance. That means both resistive part and yeah, reactive part also included in this impedance. So for this reason, here we have to consider this equivalent circuit like this. So this is the two terminals A and B. So now the driving point resistance at the terminals A and B when all internal sources are killed. So if you want to find the ZTH or RTH, Thevenin's resistance, how many number of sources are there? It may be a voltage source or current source. We have to kill all the sources. So when the voltage source is there, we just kill or remove this voltage source and short circuit this particular area, and finally we can find this RTH or ZTH. In case if you consider current source is present in the circuit, we just kill this current source and open circuit that place, and we have to find the RTH value or ZTH value, depends on the AC circuit or DC circuit. So here we are going to see only DC circuit, so you must use RTH is a Thevenin's resistance and VTH is a Thevenin's voltage. So the load current can be determined with the help of this formula. IL is equal to VTH divided by RTH plus RL, where VTH is a Thevenin's voltage, RTH is a Thevenin's resistance, and RL is a load resistance. So with the help of this three parameter, we can able to find the unknown parameter load current IL. So what are the steps to be followed for finding this IL, or what is the load power for the particular load? Everything can be determined with the help of some steps. So first you have to consider the load resistance. What are the given circuit is available in your example, that should be identified properly, and you have to find which is the load resistance, and the load resistance as denoted as RL through the current flow through this RL resistor is determined as a or denoted as a IL. So the mark the terminals A and B across this load resistor RL, so which is connected. So and blindly we can draw the Thevenin's equivalent circuit between terminals A and B, and it is a constant voltage source with voltage VTH and resistance RTH. So this is your given example. So Vs is the source voltage which is given, R1, R2, R3 and load resistor. RL is in between of terminals A and B. So to find the VTH, you have to disconnect the RL and read the circuit. After removing RL, we can able to find the what is the Thevenin's voltage between of this two terminals A and B. And from the above circuit, we kill all the energy sources. So what are the given voltage source or current sources given? We removed everything and look back at it. After that, we can able to find the RTH. So if you have a voltage source, we just short circuit it. We can able to find the RTH, and if it is a current source, you just remove it and open circuit it. We can able to find the RTH. So finally, RTH is equal to VTH divided by ISC. That is, VTH is a open circuit voltage, ISC is a short circuit current. So IL is VTH divided by RTH plus RL, and load power PL is equal to IL square into RL. So these are the steps to be followed to find any unknown load current with the help of Thevenin's theorem concept. So let us see the problem. So here we consider determine the current I in the network by using Thevenin's theorem. So here we have two sources, voltage source 10 volt and 12 volt. So the polarity is positive and negative, which is connected. So from this polarity of voltage sources, we can identify this circuit is a DC circuit. So here two resistors 4 ohm and 6 ohms are connected in series with this two voltage sources, and along with this A terminal and B terminal is there, and in between of these two terminal 10 ohm is connected. So now this 10 ohm is a load resistance, and we have to find the current flow through this load resistance RL, which is denoted as I and IL. So this is the equivalent circuit for Thevenin's theorem. So in step 1, we can draw the equivalent Thevenin circuit. So VTH and RTH and RL. So from this we can find IL is equal to VTH divided by RTH plus RL. So for determination of VTH and RTH, we proceed the procedure what we have seen already. So in step 2, from the given circuit, we just disconnect our RL, that is load resistor. So this load resistor is now removed in between of these two terminals A and B, and 4 ohm 10 volt is retained and 6 ohm 12 volt also retained. We have to find the what is the Thevenin's voltage in between of these two terminals. So with the help of this rule, so I is equal to, here two voltage sources are there and two resistance also there. With the help of this simple concept V equal to I into R, Ohm's law concept, we can able to find this I value. So I is equal to 12 volt minus 10 volt divided by 4 ohm plus 6 ohm. Finally we get 0.2 amps. So this 0.2 amps is the current I. After that, that means the current flow through this particular area. And VTH, which is equal to VAB, that means in between of these two terminal, what is the voltage, that is open circuit voltage, because we remove the load resistor RL. So VTH is equal to VAB is equal to VOC, which can be determined by these two values, 6 into I. 6 is the resistor value and the current is I minus 12 volt. So now 6 into 0.2 minus 12, which is equal to minus 0.8 volts. So from this we can identify B terminal is a negative polarity terminal, A terminal is a positive polarity terminal. So finally we get an answer VTH is equal to 10.8 volt or minus 10.8 volt. So in step 3 we can calculate the RTH Thevenin's resistance. So here we just kill the RL load resistance from the given circuit and also two sources which is connected in the circuit. Everything is removed. Two sources are voltage source. We remove it and short circuit it, and we just remove the load resistor RL. So this is your circuit which is replaced, and we can remove the load resistor RL and two sources. So 4 ohm and 6 ohm both are connected in parallel. So now we can find RTH value, which is equal to RAB. Two resistors are connected in parallel. The formula is 4 into 6 plus 4 plus 6, which is equal to 2.4 ohms. So this is RTH value. So next we can find load current IL. So IL can be determined with the help of formula VTH divided by RTH plus RL. So 10.8 value is the VTH and RTH is equal to 2.4. RL is given already in the circuit 10 ohm. So finally we apply all this value in this formula and finally we get a 0.87 amps. So the load current 0.871 amps is the current flow through this 10 ohm resistor. This 10 ohm resistor act as a load resistor for this given circuit. So this is the method which is used for finding unknown parameter of load current using Thevenin's theorem. Thank you all. Hope everyone understand this concept. Kindly go through my videos, and if you have any doubts, ask me and subscribe my channel. Thank you all.